Hello everyone. Hello dear Java fellows. Welcome to Jacob webinar. Glad to see you all here. We still have a couple minutes for everyone to join, so I hope more people will come soon. My name is Roman. I'm a driver of Jacob Initiative, and I'm really glad to see you all here and on all our webinars. Thank you very much for being with us. Thank you very much for joining our community. Thank you very much for trusting our webinars, and thank you for your interest. So today we have yet another interesting topic and really great speaker. I hope this would be really useful and you will love it. So not to miss our talks, you may find in the description of this talk link to our community page. So you may go there and register and sign up for our community. You will receive all notifications about all our events and about everything we do. So do that. And also you may subscribe to this YouTube channel. And here we have all our webinars and all our recordings. They appeared on this channel. So if you subscribe for it, you won't miss any new updates. Also for be pleasant for YouTube algorithms, you may click a subscribe button and you may click bell button. And you may click like button for this video, so YouTube will know that this video is useful and this channel brings useful information for people. So more people will come to our community, and we will have possibly more interesting topics, because with more people come more great speakers, you know. And yeah, this is really my suggestion. Please do that. It's not like for me myself, but of course as well. But more of these for YouTube algorithms to work. Before I invite my speaker, my today speaker here, I want to remind you that we really appreciate your feedback after all our webinars. If you register on the talk on our community page, you will receive an email with feedback requests. So please spend a couple minutes to fill it, and we will know your opinion, and we will know how to make our webinars better. And also, great announcement, Java On Conference 2023 is announced already. It will happen in November this year. You may find all information on our community page. Please submit your talks. If you want to be a speaker on the conference, call for paper is open. Submit your talks there, and also you may register for the conference already, so not to miss it. It will be in the beginning of November. Free conference online as previous year. All videos from previous year you may find on our YouTube channel. Everything is there. Glad to see you there. Yes, it is online. It is online conference. Okay, so not to spend more time, let me invite here today my guest, my friend, our great speaker, Alexander Mamin. Hi, Alex. Welcome.
Hello, Roman. Nice to meet you. Nice to see you again, and nice to be a speaker on this fantastic Jacob initiative. So, how are you doing? What's the weather in your location right now?
Well, it's sunny. We have some storm. We have some storm and some rain, but in the morning, yeah, we had it. So now it's sunny as always, mostly. How it's going in London?
Well, what I want to say is that weather in London is not so good today. Well, it was super sunny yesterday, but it's a little cloudy today. So hope it will be better. Other than that, today is a public holiday, so I'm really happy to spend some time with you today because, well, I've been to Seaside yesterday already, so why shouldn't I be as a speaker on this event today?
Yeah, thanks a lot for spending your public holiday, for sharing some Java knowledge with us. Thanks a lot. So today your talk would be about something quite modern, about GraalVM and Spring Native. So could you tell us a couple of words? What would it be about?
Oh, okay. So talk's name consists of two parts, Spring Native and GraalVM bird eye view. So it will be a very short introduction into what you should use in order to build your first in order to build your first native image, what caveats you should be aware of, and how you can start using it together with Spring. So this is what it will all about today. So nothing super outstanding, but still quite useful engineering knowledge in case if you'd like to start using it.
Yeah, I do hope that will be really useful. So, guys, just a reminder, we have two chats where I will collect all your questions and all your comments. First chat is in the YouTube right here, and second one is on We Are Community platform. So you may use both of them to post your questions or comments regarding the talk. I will announce these questions to Alex when we will have some pauses, and we will try to speak of them or elaborate them or ask or answer them. This is what we will try to do. Okay, so I would say let's not waste more time. Maybe you guys can share this link with some of your colleagues. Just say, hey, there's great talk there. Come and join. That would be useful. Okay, so good luck, Alex. I will share your screen. Let me do that. We're here. We're ready. Good luck. Let's go.
Thank you very much, Roman. So let's go ahead. It's going to be a practical talk, and I do not have a lot of slides today, but still, this is my first slide, and as ordinary, I talk a little about myself. I'm Chief Software Engineer, as Roman mentioned. I have a lot of years of experience in software engineering. Officially, I started in 2010, but my first line of code was written in 1995. It was in BASIC many years ago. Apart from that, I'm also head of UK engineering community, and if you'd like to have more talks about different topics and you'd like to contribute to UK engineering, so please join our community. Link is at the end. Apart from that, is ordinary agenda. So this is what we will talk about today, but mostly it will be live coding. Just a few slides. What's GraalVM, how to build, how to start, and how can this help Spring. So let's start with GraalVM. Well, it was developed by Oracle, and in a nutshell, it is a high-performance JDK distribution designed to accelerate Java application performance while consuming fewer resources. So, and actually, GraalVM can be connected to your application in two different ways. First of all, you can you can run your application on top of virtual machine and use GraalVM as a just-in-time compiler. So in this case, what it will do, it will, as ordinary, collect some statistics about the usage of your code and next convert it into the native code. Ordinary just-in-time compilation, but it is not something which we have not had before, because the killer feature is ahead of time compilation, which allows us to build native executables. Besides Java, we can use GraalVM to build native executables for different languages and even mix programming different languages in one binary. So at the moment, you can use it for Java, for JavaScript, Ruby, Python, WebAssembly, and even more. So let's start. So what we need to have in order to start using GraalVM. So first of all, we need to install it, and the easiest way to do it is to use SDKman. So if you never used SDKman, I strongly recommend you to start using it. So this is my terminal, and during today's talk, we will spend majority of time here, and also I will share some links. So if you never used SDKman, so you can install it from sdkman.io and next using it. So why? Because it allows me to see what exact let's say tools are already installed. For example, I develop different things, I test different things, so that, as you may see, I have different installations of Java itself from different vendors. JDK from Caretta, from Graal, from Java.net, OpenJDK, JDK from Liberica, and so on. But what's more important for me is that it allows me also to install Graal. So the first thing every programmer does at the very beginning of the career is hello world. So let's run our application. Let's write a simple hello world. Let me show that it works to make sure that it works. So what I'm doing right now, I'm building it as ordinary, and next I am running it. As you may see, it works. So let me select a proper JDK installation. So SDK list Java, it shows that I have a lot of them. And here what I can do, I can install, I can select different JDK installations. So SDK use Java with one, and Java minus version also tells that at the moment I am using GraalVM. So let me compile. So in this scenario, I'm using target classes, Java, def, abarmin. I am using GraalVM not as I am using GraalVM not for compiling and building native executables. I am using it as ordinary JDK, let's say as an ordinary JDK. So because it also allows me to build my Java application and also allow me to run it. So obviously our next step is to try to build native image for this simple application. So it's a super simple application, nothing outstanding. And in order to do that, I need to make sure that I have installed a plugin. So in order to plugin for building native images for Graal, so which helped me. In order to do that, I need to first of all take a look into the list of all the Graal utils which are installed. So as you may see, I have native image component already installed. If I did not have it, I can do it just by executing gu install native image. So, but next it will go to graalvm.org website and download it. So what's next step for me here is to convert my Hello World application, simplest Hello World application, into the native executable. So how can I do that? Actually, it's super simple. I'm going to the classes directory again, and in this scenario, what I'm doing, I'm calling native image command. And so what I need to do, I need to copy paste the reference to the main class, which will be an entry point. And next, the native executable is starting to build. So as you may see, it is happening, and it will take for this simple application around 30 seconds. And what's happening under the hood here? So Graal is following the closed world assumption. What does it mean? It means that all the code which is available at the build time is all the code we will have during execution. So that's what we can do. We can make an assumption that we will not any new code in the execution time, in the runtime. So let's see what built. So as you may see, I built a native executable. So this is executable, and it has a quite small size, around 11 megabytes, and I can run it. Okay, so hooray, hooray. Right now you're familiar with GraalVM and you can do it on your own. You can convert all your applications into the native executables. It's simple. So, but obviously we're not compiling Java from command line at the moment, where we have fantastic tools like Maven Gradle, which allows us to do the same, but in easier way. And the first thing first, in order to build native executable using Maven, we need to add a plugin. So this is my native Maven plugin. This native Maven plugin is connected to the build phase, and it allows me to build my native executable, but not from not directly, but using ordinary Maven build phase. So let me do that. Maven clean package -p native. I added a profile because it's in profile native, which is not activated by default. And right now, when I'm activating it, I'm getting a error just because it seems I'm in the wrong folder. Clean package -p native. Okay, so what I need to do in order to start using this build tool? In order to start using this build tool, first of all, what I need to do is to show what is my main class, because as you remember, what it does, it starts analyzing, start analysis of the Java application of the invocation tree from the entry point and next go down. So while it compiles, I again can back and continue telling stories about closed world assumption. You may ask, well, come on, my application consists of one single class. What it does for so long? And actually, it analyzes not only your code, but it also analyzes code which is included into the JDK, because even in order to run so small application which outputs hello world, I need to have things like system out, and all these things like system out live in JDK distribution, so that these classes are also analyzed. And at the end, I'm getting the same artifact in the target directory, my hello world app of 11 megabyte size, and hooray, it works. Roman, what do you think? Should we stop our talk right here? Because it seems we already know everything we need to do.
I would say that if you ask, probably we have something else to share, right?
Yes, definitely. We have a lot of things to do. So let me get back to my slides and continue. So as I said, GraalVM is following the closed world optimization, so that it builds native images, and obviously native images are not executed on their own. These native images are executed on top of Substrat virtual machine, which also does some memory management. It also does garbage collection, thread scheduling, and other ordinary JVM features. But not all the features, not all the features of we all used to have are supported. And here we have some problems, because in case if we have closed world optimization, it means that, and closed world assumption, it means that all the classes which we build in which we include into our executable should be available at compile time. So that we're starting to get some issues with things like dynamic class loading, reflection, dynamic proxy, GNI, and serialization. But obviously, engineers from Oracle already know everything about it, because they have already considered many different, let's say, they have already considered many different projects, and they know that reflection, for example, is a tool which is very, very widely used in our application, so that we cannot just tell everyone not to use it. And here we have a couple of options. Okay, let's start with the next application. So my next application is again a simple terminal application which does a few things for me. So let me run it for you in order you to see what it does. And as you may see, I have a configuration here in the IntelliJ. Let me remove this configuration, because otherwise I will not see full details of my software. So as you may see, it's a simple terminal application which says that in order to run, I need to provide a class name just because as a program argument, just because what is happening next is it reads a program argument, takes the first one, load the class using class for name. Well, this involves class loading and class loader. And next takes the first declared constructor. And using first declared constructor, it creates a new instance. And next step, I know that name of the class I'm providing here is my hello world provider. It implements supplier interface and returns hello world. And what we're doing next, we're executing this hello world and finally go through all the declared methods. Nothing outstanding, right? Right. So if I run this software in the JVM mode, surprisingly, it will work. So because at the moment I'm running it on top of ordinary JVM, and ordinary JVM works gracefully with things like reflection, class loading, and so on. So let's take a step forward and let's try to build the same software, but using Graal. So what I want to do first is obviously SDK use Java. Oops, I need to select a proper Java in order to run it. Right. Because otherwise my experiment will not be so successful. SDK list Java. What I'm doing next, I'm copy pasting this version of Graal, SDK, use Java. Okay, so let's go into my actually I also have a test for this scenario to prove that everything is working, my software is working, because we're all writing tests in order to make sure that everything is okay. So what I have is I have my POM file, and in the POM file I have dependencies, and apart from dependencies I have couple of profiles because it significantly simplifies building. So let me compile my application. As ordinary using Maven, clean compile without profiles. And next, I'm going to the target classes. And what I'm doing next, I am building a native image for my application. So again, build will not take a lot of time, but still will take some time because it is Graal. You can imagine how much time it takes to build. It will take to build your ordinary application, which has hundreds of classes, dozens of dependencies, and so on. So it will be painful. So my image is being built, almost being built. So, and while it is happening, I suppose you are not noticing any suspicious thing. Okay, so I have my 11 megabytes executable. Let me run it. Okay, it complains that I need to provide a class to use. Hooray, works. But surprisingly, it a little contradicts with what I said before, that all the classes should be available at compile time. And actually, in case if we scroll up, native image compiler noticed that it seems that I am doing something suspicious. And for example, here in my application, I'm calling get declared methods, get declared construction, which looks suspicious to Graal compilers. So that what it does, it builds a native image, which is not really native. It is native image which uses ordinary JDK distribution under the hood, because here what it says is that, well, I didn't manage to generate, let's say, application with closed world assumption, because I see it seems that some reflection is used, so that I will build another image which will use GraalVM as a runtime environment, but I will collect all the artifacts into one single image. So I still have native executable, but in this scenario, it is not, let's say, starting everything as a specific program for my computer, for my architecture. It is ordinary JVM packed into the binary. So what can we do? And as you may see, in case if I'm executing this command, in case if I'm running this program, everything is working as expected. So let's try to switch off this fallback and see what will happen. So in order to switch off this fallback, what I can do, I can as ordinary use I can use oops, obviously can build it from terminal package. But apart from that, I can add this parameter no fallback as a build argument into the Maven plugin. So let's see what will happen. Let's see what will happen. So what's the difference in comparison with the previous step? So in previous step, I have not provided this no fallback option, so that Graal noticed that I'm using reflection. So that it said that, sorry, I will not build a fully native image for you. What I will do, I will build a fallback image for you. So as you may see right now, it took again 26 seconds to build a simple application. This time it has not complained about anything, and let's go and try to run it. cd target, and where is my hello world application? It's here, says that you need to provide a class name. Wow, it fails. Obviously, it fails because class which I hello world provider is not included into the binary. So what can we do in order to explain to Graal that, well, actually, I know that this class is not used anywhere, but next I will definitely use it in my application. So there are a couple of options. So let me start with options. So what we need to do in order to explain Graal what classes to include into the final image, we need to create a meta-inf folder, and inside meta-inf folder, we're creating a folder native image, and next our group ID, artifact ID. So, and here we have a couple of options. So option first, let me uncomment it, is we can say that our reflection will be configured by file called reflection config. And in the reflection config, what I may do is I can say that this particular class with a given name should be included into my final image because I am using it in runtime. So let's build the image and see what will happen. So I included only the class name. You have already seen that. Oops, what's up? It failed because reflection config does not exist. Surprisingly, it was working. Let me double check if I have everything. Reflection config.
Maybe I don't know. Maybe repackage could
Yes,
help.
it ordinary helps. Okay, so package minus profile native should work. No worries. I checked everything yesterday, and I surprisingly noticed, for example, for my examples for Spring, that everything is slightly outdated. Okay, so this is something which okay. So I suppose also what I need to do is to use another version of Graal, because I noticed that some features are working okay with some versions, other features are not working okay. Okay, surprisingly, it says file does not exist. Let's check. Let's check. So cool. Oh, sorry, I think I know. Maven clean compile. I need to compile it first. Come on. And next, what I may do is I may convert Maven Maven minus. An example, by the way. I have a helper. I have a helper for myself, and so my helper says that Maven clean package minus p native. Now it should work. Opa.
So guys, just a reminder that we're still looking for your questions. If you have any, just post them in the chat. We have some, and we have some discussions there. But like, also we had a question regarding reflection, which we're currently trying to
Yeah.
answer, basically.
Yeah, so I like it. I like the cases when it does not work, but still as ordinary I have another option. Let me check if it will work. Because, well, what I wanted to show, I can show in a different matter as well. Even in case if this approach does not work, so there is another approach. So what I wanted to show is that we can enable and we can explain to Graal that classes we need to deal with and the classes which should be loaded during the compile time should be are defined in my reflection.json config. So what I'm saying here is that this is name of the class, and I am allowing to access given set of methods via reflection, and I'm also allowing to query all the declared methods as well. So let me check that it still works. Example, reflection, target, hello world up. Where is my favorite up? And let me call it again. As you may see, everything works. Obviously, it is not super convenient to do all these things in JSON because you have already noticed it is sporadic. It may not work sporadically. So that we have a different option. Instead of just saying that all the configuration lives in the reflection.json file, we can say that, well, I know what to do and I will configure everything I need, not in JSON because it's error prone, but I will configure everything using the feature. So in this case, this is a reference to my class which implements the feature interface. This is a class from native image hosted package. And what I am doing here, I'm saying that, well, I'm registering for reflection my hello world provider, and I'm also allowing it for reflective instantiation. And also I'm allowing to go through all the methods in this class. So let's assume I commented out this line in order to show you how it works. And let me build this application again. So while I'm building my application, again, it will be compiled successfully. The native image will be built successfully. But still, I will have some limitations. While it is building, let me take some water. Okay, it's finally here. Where is my favorite application? So as you may see, it works. All the steps are working as expected, except last one, I cannot get access to declared methods. So is it good? Well, I suppose it's good, but still, it would be nice. To make sure that application is working as expected before we run it. And in order to do that, what we ordinarily do, we write tests, aren't we? Right? We write tests to make sure that application, in case if it is successfully built, it can be used in production. So that what we noticed is that despite the fact that application is built, it does not work, and even our tests cannot prove it. So this is my simple test, and in the GraalVM mode, it works gracefully. But what it does is, again, it loads class, get default constructor, and create instance from it. Other than that, I have my test message provider, which is not part of my, let's say, main main source set, but it is part of test source set. So that it would be nice to execute my tests and not in the GraalVM mode, but in the native image mode. And in order to do that, what I can use, I again can use Maven profile. and some Maven native plugin. And in order to do that, I am adding this goal into the test phase. So let me build it again. It's another Maven profile, but with native test. Oops, was the name of profile, native test. Again, I'm in wrong folder. And as you may see, what's happening in this exact scenario. So before executing the tests, GraalVM builds images, native images, and execute tests against them. So in order to use this approach, you don't need to change anything in your application. What you need to make sure is that you're using fifth version of JUnit, because fifth version of JUnit already supports everything you need. So in case if you want to use feature classes in your application and declare some dependencies, which should be included into final image, you need to add this dependency. Okay, my tests failed just because I expected it. So as you may see, it shows that, well, it seems everything was fine. One test is successful, one test is failed. And the reason why it fails is because test message provider, which works, which is not part of my feature file, and not registered in my feature file, is not in the native image. So that it allows me to prove that everything which was built should work. Okay, so it seems that right now we know almost everything we need to do in order to build and test native images. So to wrap up this part, I'd like to say that the easiest way to do it is to register, for example, a reflection file or register a reflection class or feature class, which will, let's say, do registration of everything for us. Well, but anyway, it's hardly unlikely you will write application on your own. And by the way, you also should be aware that not all the features are compatible with closed world optimization. For example, security manager, which is deprecated and to be removed or already removed, is not compatible with closed world optimization. And work dynamic is also does not work. But apart from that, it is also recommended to be aware that some features like class initializers, unsafe memory access, of these features may work in native image differently. Okay, so, but as I said, we hardly unlikely will write our application in plain Java. More likely we will use one of the popular frameworks. More likely it will be Spring, because it's used widely, and Spring team did great job in order to make support of GraalVM simple. Because I tried to use GraalVM with Spring 2.7, it was a bit painful, and in Spring Boot 3, it is outstandingly easy. What's happening? So the root, let's say, main part of this tricky thing, how to make Spring working with native executables and with Graal, is we need to get rid of reflection. We all know that Spring uses reflection a lot under the hood, and it uses it for almost everything, for building, for dealing with transactions, for building web clients, for let's say for creating instances, almost for everything. So in order to use all the existing code, which is already written with GraalVM, what we need to do, we need to execute as much as we can during build time. So that we have main plugin here, which is Spring AUT. What it does, When we build our Spring application, we are building application bytecode. And what Spring AUT plugin does next, it generates additional set of sources. It executes bin post-processors if possible. It adds aspects during compile time and build additional bytecode. We will see it shortly. Apart from that, we also know that we have a lot of configuration which we need to generate for GraalVM to work. For example, this reflection configured JSON file. And Spring AUT plugin does it for us as well. And when all these pieces are built, our own bytecode for print components, next we're, let's say, uh, moving this to batches to native image compiler and getting native image. Let's see it in action. Let's see it in action. So, by the way, Roman, are there any questions so far?
Yeah, there are a couple questions. One of them is related to GraalVM and its usage with together with Cloud Functions. So, question is, how does it work? Have you checked that? Yeah. So, first question to you, then I will add my addition.
Okay, so with Cloud Function, I suppose. Well, let me select proper Java version. SDK use Java, and let me SDK use Java, and let me run Maven clean package while everything is happening. Yeah,
Yeah,
because
it takes some time.
yes, because right now it takes time. And answer the question. So, so as you may see right now, it is built easily, but also we have a different plugin which allows us to build native images from scratch easily. Spring Boot builds image minus p native. So this is what we need to do in order to build native executable for Spring. And I will tell a little about different options. So answering about GraalVM with Cloud Functions, it can be easily used. But there are some limitations. What you need to do in order to use it, you need to build Docker images. And this is actually what we're doing right now, because let's say you can not upload your binary directly to the cloud, unfortunately. Well, you can even upload your jar file as a you can upload, let's say, your sources of your jar file or your jar artifact into S3 bucket and run it next in AWS as a AWS Lambda. It will gracefully work. But in order to run native executable, you need to build it locally or build it on CI somewhere. And next step for you is to create a Docker image and run Docker image. So you're not running, let's say, native executable directly. You're running Docker. You're building Docker image. From Docker image, you're creating container and running this container in your function. Yeah, it will help additional overhead, obviously, but still, this additional overhead will be maybe much less in comparison with running a native Java application, especially, for example, in case if it is using some heavyweight framework like Hibernate. So to answer your question directly, you cannot run it in cloud directly, but apart from that, what you can do, you can build image and run application. You can build Docker image and run Docker container as a function. It will work as well. Apart from that, what I need to mention is that it is a known issue to cloud providers that building of images is taking time. As you may see, I'm still building my Hello World application, and it will take around 6 minutes. And I will show a couple of ways how to do it, and more likely right now I will stop, but I did it in order you to see. Nevertheless, cloud providers are doing some work in order to make running of Java in cloud not so painful, especially in the Lambda in serverless functions. For example, AWS, what they did is that they understood that it takes a lot of time to run Java. So this is, let's say, warm-up time, initiation time, and next this is a small piece of time, small amount of time which is required in order to execute Java because it's quite quick. So what we decided to do is, instead of building images for um, not warmed up Java application, we decided, why shouldn't we run our application, your Java application, and create a snapshot not at this time, but at this time when your application is already started. And next time you start your Lambda, it is not starting from scratch. It takes, let's say, running saved snapshot, which already instantiated, loaded all the classes, instantiated all of them, and next it's ready to execute. So this is what they done. And definitely it's allowed to significantly reduce startup time. So this is what they did. Well, I'm still waiting my Java,
Yeah.
my Spring application to be built.
I, I just wanted one small comment. So regarding usage of GraalVM and lambdas and all this stuff, we have Alex Filichkin. We had his talk on our channel, and also he has some nice topics described in his. I forget the name of the site where he put his articles, but still he has a nice investigation on this part. So I will refer to it for this question as well.
Okay, so what's happening right now? Right now we're struggling to build a Docker image, and I suppose I will stop it right here because it was one single option to do that. So in what we have in Spring, when we are using Spring, we have a Spring Boot Maven plugin or Gradle plugin, and what it does for us is it actually does a lot of things for us. It allows us to, let's say, build fat jar with minimal efforts. And before we proceed, let me explain what we need to do in order to start using Graal together with Spring. Actually, at the moment, nothing. Because as you may see, I am not adding any additional dependencies with my ordinary dependencies, Spring Data JPA, Spring Boot Starter, and dependency for Spring Test. This plugin is automatically added in order to enhance my Hibernate entities, because Hibernate is also dealing a lot with reflections, so that it requires additional work to use these entities. And in order not to do it in runtime, we are doing it in compile time. And the second thing is obviously Spring Boot Maven plugin, which does a lot for us, and native Maven plugin. If you go to start.spring.io and add Spring Native dependency, all these plugins will be configured automatically for you. So let me try to stop building the image finally, because it is taking too much. So as you may notice, building this small application as a native executable is taking a lot of time. And before proceeding, I need to explain why it is taking so much time. Because in Spring, we have Spring Maven plugin, and Spring Maven plugin allows us to build a couple of things. So first of all, if we execute Spring, in case if we take a look into the list of available options, we will see that it allows us not only to run start, stop, and test, run, repackage, and all that stuff with our application, it also allows us to build image. So what this build image does for us, there is a quite convenient tool which is called buildpack. Buildpack allow you to convert your own application into the Docker image. Why it is convenient? It is because you don't need to take care about Docker file. You don't need to think about, let's say, latest security updates, whether you're using proper Java version, whether you set all the environment variables for memory correctly, whether you configured, let's say, your Java application in order to know everything about Docker and so on. So instead of doing all these things manually, what you can do, you can just, let's say, use Spring build image, and Spring build image will build this image for you. So as you may see, it is finally done. So, and this is the application which was built from native application, which was built on my computer. As you may see, it took 7 minutes. Let me run it. Docker run name. And it gracefully starts very quick and also fails very quick because it requires database, but I have not started it. But nevertheless, you see that the starting of this application is not taking a lot of time. So it started, let's say, within milliseconds, as Oracle promises. But by the way, you can run. I have Docker compose app database. Let me run Postgres. And let me run my application in another terminal. Docker run. Need to forward some ports. 80, 80, 80, 80. So my application successfully started, but well, not connecting, but it really doesn't matter because I have it all, because at least it works. So at least it starts, tries to connect to database, but it seems something is not really good with my laptop today. It's second example which is not working, but still. So it tries to connect to database in Docker, and it seems database is not available. Anyway, so this is the first thing which you may do in order to build image. But in order to run the application, you don't always need to build images. You also have a second option. You can use native Maven plugin, this plugin, native Maven plugin. And in order to use it, obviously doing the same, clean package, native compile, or just clean native compile. And what's important is that you need to use this native profile. In this time, it is not profile which I declared. This time, this native profile is provided for us by Spring Maven plugin and Spring Parent POM. And what it will do the same, but a bit quicker, because right now build is not happening in the Docker container. Right now, build is happening on my computer, and at least I can stop it. So I stopped it. Okay, so it seems that everything is working in Spring out of the box, apart from connection to the database. Is a simple hello world application which does nothing, but still it should work, shouldn't it? Yes. But let's take a look into our favorite example with bean post processors, because we're talking about bean post processors every day. But I have written, let's say, maybe couple of Spring post processors in my life so far, but still it is very popular topic, so that we cannot avoid talking about it. SDK list Java is ordinary to select a proper JDK, because I'm switching between IntelliJ. SDK use Java, proper Java. And let me show you a few things. So this is again my simple Spring application. What it does is it calls custom service and asks custom service to do something. Custom service is an interface. I have implementation, and on top of my implementation, there is a log around annotation. This log around annotation is captured by bean post processor, because I promised to build bean post processor. And what it does is around every method, it logs start time and end time. This is how we do performance, let's say, tuning. This is how we do tracing, logging, and everything. We're just creating bean post processors, aren't we? Right. So what should I do next is obviously clean native. I need to build native compile -p native. I need to build native executable. And well, Obviously, before doing that, I should have been shown that application is working, but more likely you can believe me that application is working in JVM mode as expected. So this application is much smaller and it will not take so much time to build, maybe let's say just a couple of minutes. And while showing that, while build is happening, let me show my pom.xml in order you to believe that there is nothing outstanding. So what I have in my POM is actually section few dependencies, Spring Boot Starter, Spring Boot Starter test, and that's it. So minimum set of dependencies. I have no configuration for plugins at the moment, only native Maven plugin and Spring Boot Maven plugins, so nothing else should work out of the box. And because I am providing native plug profile, it is also building Java Spring Boot application for me, build FireJar, and so on. So as I said, in order to build a Spring application, we need to do a lot of work because Spring uses reflection a lot, and here Spring AOT plugin helps us a lot because if we take a look into the list of build classes, we will see that actually it added a few additional classes for everything. So this is my, for example, service. Come on. Okay, it takes resources to build it. So this is my service. As you may see, there is nothing outstanding here. We will take a look into other parts of the service a bit later, because it is another trick you should be aware of. But what it does nothing except do something method. So for this service, I have a bin definition. So instead of, let's say, reading bin definition on the fly during the first start of the application, right now I have a bin definition class separately. And as you remember, what Spring does when it starts, it scans class path, finds all the sources for bin definitions. Next, it register all the bin definitions. Next, it bin definitions are post processed. Next, instances are created, and so on. So, in order not to do everything during the start time, right now, Spring AOT plugin generated code which creates bin definitions and apply all the necessary configuration. So for example, right here, this is definition for my custom service implementation. And this is bin definition for it. And it is saying that, well, my bin definition should be afterwired because more likely it has dependencies. Because if we take a look into my class again, it has dependencies. This is my resource. So this resource should be somehow injected into my bin. And again, we're not doing it. We are not doing it. Well, we're doing it actually in runtime because we're creating instances in runtime, but we're not, let's say, not finding fields for injection in runtime. We all know about it in compile time. So field is required field, and it should be, let's say, value for this field should be resolved when application start, and value should be set. So what I have apart from that, apart from two additional classes per my own class, Spring also creates a bin definition registration. It is another important class which is generated by Spring AOT, and as you may see here, it generates full list of bins which should be created when application starts. So actually, if you think that Spring is not a really fat framework, you may notice that it is quite, let's say, big framework because it creates a lot of classes when it starts. Ooh, many of them. And as you may see, this is my Hello World application. This is my bin post processor, and this is my custom service. And this has been definition for it. So instead of doing it in runtime and find bin definition via reflection, everything is done in advance. So finally my native executable is built, and let me run it. It does not work. unsurprisingly does not work despite the fact that it was built successfully. Because what it says that I cannot create instance of my bin just because dynamic proxy is not available. We should fix it. Why Spring has not understood that I need to do it on that I'm creating I'm wrapping this bin into the proxy. Well, Spring is clever, but not so clever because this is my own code, and here I need to explain not only Spring, but more I need to explain it to Graal. So how can I fix it? Let me do a simple fix for it first. Next, we will run build again, and next I will continue telling my stories again, how I fixed it. So because again, unfortunately, it is Graal and it takes time, even to build so small application. So in order to run, in order to allow dealing with proxies, I need to tell explicitly which classes I'm going to proxy. And in this scenario, this time, I'm not telling it to Graal. This time I need to explain it to Spring, because Spring will generate additional files like reflection config for me. And in Spring, in order to explain it, I need to create additional class and implement a runtime hits register interface. So what this hints register interface does, it actually allows me to register all these prohibited operations in order GraalVM to know about it. So what's the difference in this scenario? And this is the first step. And second step, in order to start using it, I need to declare this class in the import runtime hints annotation on top of any class which is annotated with configuration annotation. For example, Spring Boot application is also meta annotation. It has configuration on top of it. So here it works as well. So what I'm doing, I'm saying that, well, when you will run Spring AUT plugin, also please take a look into the hints which I provided, because these hints are saying that, for example, in the first scenario, I'm going to use proxy for my bin. So what will happen under the hood? Under the hood, Spring obviously will generate a lot of stuff for us. So apart from these classes, it will also generate configuration for dependencies, obviously. And apart from that, it will generate a few more classes which has not appeared yet, a few more files which has not appeared yet, but should be somewhere here. Let me take a look into them. Meta inf, reflection config, dev. This time it took much quicker, surprisingly. Okay. Let's run the application again. Okay, so as you may see, this time application started. It managed to create an instance of the bin of Hello World bin application. Next step, what happened is that my bin postprocessor managed to proxy my bin, and next invocation successfully happened. But what happened next is, again, I got an exception. So let me run build again, and next let me continue talking about things which is not working. So as you may see, I'm breaking my code again and again and again, fixing and explaining. And the reason I'm starting everything in advance is because it takes time. So let's take a look into my service again. So apart from annotation on top of it, I also have resources. And at the very beginning of this code, what I do is I am reading from a resource which is declared right here. But as you remember, it failed and didn't manage even to read from it. So read resources does nothing but creates input stream from provided resource and read first line, nothing else. So I'm intentionally not using anything more complicated, like commons utils or maybe a Lombok, just because it will take more longer to build. So that code is as simple as possible. So what I'm doing here is I am reading from resource, but it is not working. And actually, I should have a way to fix it. Main way for me to fix it. Graal, reachable metadata. I suppose I don't see these classes because I don't see these classes just because they have not been generated. Okay, so my next step here is I need to explain Spring that these files also should be included into the final native executable. And apart from that, they also should be registered with Graal. And in order to do that, I am doing the second thing. I'm registering my resources. I need to clearly say that I am registering resources hint, and this is the pattern which I'm going to use for resources, because resource dash asterisk. So it says that all the files which starts with resource and has txt extension should be included into my final build. So let me check because there should be a few additional files which I don't see right now. Let me reload everything from disk. Yep, so it's finally here. Let me run application in order you to believe that everything is working. Where is my file? I'm running it and everything works successfully. So all the values are received and right now application works without failures. So what it does for us, actually this registrar registers components into register components for Spring AUT, and Spring AUT generates a few files for us. So first of all, what it does, it generates native image properties, saying that this is my main class. And please don't use any fallback. Please don't generate the image with JVM. I'm building a really native image. Apart from that, it creates a reflect config class. As you remember from the first example, reflect config classes, reflect config JSON config file is used for declaring which methods should be accessible via reflection. And as you may see, Spring AUT plugin generates everything for us, for almost everything. For example, this is my bean post processor. Bean post processor should be possible to create it via reflection. And in case if I decide to, let's say, go through all the methods using get declared methods, this also should work. So all these classes are registered here. Apart from that, I also declared that my custom service will be proxied, so that Spring AUT plugin generated proxy config for me. And here saying that this exact class will be used together with dynamic proxy. Apart from that, it created a resource config for me. So this is the resource I added, and all the other resources were here from the beginning and were added by Spring. But in order my software to work, I need to register all the files which start with resource prefix. So to sum up, right at the moment, it's much easier to use Spring with native, but still you need to be aware of some caveats and how they should be resolved. So main way to resolve everything at the moment is to use runtime hints registrar. If you, for example, dealing with Spring Boot 2, it has different set of annotation. As far as you remember, it is hints annotation. So it seems we're almost running out of time, and I have a few more slides to show. Obviously, these slides are super simple because I have already explained everything in the live coding. So Spring AUP, what it does for us, it reads configuration classes, prepares bin factory, generates code, and additional code generation is also performed. For example, reflect config, proxy config, resource config is executed for us. Other than that, it also computes all the conditional ons. And what's important is all the conditionals are evaluated based on all the parameters which are provided at the build time. Because you remember, you may have a different bin for different environments, or for example, use conditional on for feature toggling. So that in case you're building native image, uh, you need to provide all the necessary parameters when you're building it in order, let's say, not to perform all this evaluation when on in runtime. Other than that, it also evaluate profiles. You also need to provide all the profiles which you're gonna use in the build time, and generates a lot of code. So we have seen it. And actually, that's it. What I want to say is that on the one hand, yes, Spring and Graal itself allows us to build native executables which start significantly quicker, but still it requires a lot of time to be built. And maybe it is not a big problem when you're developing a small application, or when you, for example, can run Docker images on your CI, but still it slows down development a little. Other than that, as we seen, it has a lot of limitations. And it seems that the reflection is one of them, but actually it is not. For example, if you're dealing a lot with resources, you also need to register all your resources in order not to forget about them. Other than that, I want to notice that in comparison with Spring 2, in Spring 3, everything is work much smoother. So, I mean Spring Boot. So please don't forget to update to the latest version, because it seems it will be even easier in future. And there is one important thing which I haven't mentioned, but I suppose it should be mentioned, is that we may use Spring KUT plugin independently of native compiler. So what it means for us, it means that we can, let's say, do all this in upfront work during compile time, and our application, our Spring application, even in JVM mode, will start quicker, because it should not scan all the resources and execute all these bin post processor, create process, and so on, because all this work is done in advance. All the examples I shown today are available on GitHub, and also on GitHub there is a quite comprehensive explanation of what exactly I've done, what exact issues I faced, and how they should be resolved. That's it. Thank you very much, by the way.
Thank you, Alex, very much for your talk. I suppose it was really useful. We have some questions in the chat, by the way, which I will ask you. These questions are already answered by our community, but still I want us to maybe repeat it and have maybe some other answers. So, guys, thank you all who are watching us and responding in the chat to the questions. This is really valuable that we have this community which asks and answer questions. That's really cool. So, first question we have here was the following: why would I want to build native application, then package it into image when I can just build image with GVM? What are the benefits of these two approaches?
Can't you? Do you want honest answer?
Yes, always.
Actually, there is no significant. Well, there are no significant benefits. Well, apart from obvious that your application will start quicker, actually there are not so many benefits, because you actually may lose some advantages of using Java. For example, if you're running your application in Docker or in Kubernetes, it's more likely that you have application which built with microservice architecture, right? Right. And in order to observe this application, you more likely using some tools like, I don't know, Dynatrace, for example, or OpenTelemetry, or for example, Datadog. And these tools are working as Java agents. So if you're running this application in JVM mode, you will have all this instrumentation in place. But in case if you build a native image, you will not have it anymore, which is a big problem. So there are not so many reasons to build Docker images with native executables inside, but still there are some. For example, you want to run your, let's say, big application in serverless environment, when it's important for you to respond to requests. For example, you're building native image for Lambda function. Lambda function should start quickly. Another important thing is that you may use it in case if you need to address spikes in your workload very quick and don't want to waste resources. For example, you run your application in Kubernetes. Kubernetes is running in the cloud. You're paying for resources, and in order not to waste resources, you let's say when you experience a big spike of user, big spike of workload, you're starting let's say 2, 3, 10 dozens of instances quick and next switch them out as soon as they are not needed anymore. So the main benefit of using it is in case if you need to respond to your work to the spike in your load quick. That's it. Just because Java JVM version takes longer to start in comparison with native version. Native starts much quicker, but still you're losing some advantages of having JVM. So I would say it's better first of all to compare, because as ordinary it's trade-off. There is no silver bullet which solves all the problem. You need to, let's say, compare alternatives and choose which is more important for you. For example, observability or maybe performance.
Cool. Thanks a lot for the answer. Next question, I would call it also kind of provocative, but still, yeah. So it's the following. What's the benefits to use Java in serverless application when we could just develop with Python and Go and not struggle with all these native images and all this stuff?
It's a very good question, by the way, because and the answer to this question would be is why do we have so many programming languages at all? Because it would be nice to have one programming language which will works gracefully for all the use cases. For example, let it be C++ and not to insult anyone. And C++ is a great programming language, but still, for example, in it you have access to direct access to memory. You can, let's say, break your computer completely, or for example, it will take a lot of time for you to build a simple JSON converter. And the reason is we have different programming language, so that these programming languages are better for solving particular tasks. Java has a rich ecosystem, and for almost any task you have, you more likely already have a Maven module which allows you to solve it out of the box just by gluing a long XML configuration. So that some, and also there is a third reason to do that is because we already have a lot of experts in Java who are quite good in it, who can write and implement almost everything in Java, so that we also cannot just tell them, okay guys, from tomorrow you're writing Python. So this is all in all, Java is still popular because we still have a lot of applications which are written in Java, but still we also have a challenges of our modern world when everything migrates to clouds, and clouds should be used wisely. This is the reason why Oracle engineers are doing their best in order to make Java not great again, but to make Java more suitable for challenging workloads. So this is long answer, but I suppose I reasoned enough, saying that Java is good, and you cannot just go and rewrite everything you already have in Python.
Yeah, thanks a lot for this detailed answer. I would also add here that once each, I would say half a year, there is new language which should replace all others. Like 1 year ago it was Carbon, now everyone speaking again about Rust. So like in half a year it would be something else. Like, yeah, I agree here that language is just an instrument, and we here speak about how to use these instruments. So yeah. Okay, so we have a bunch of questions. I will try to combine them anyhow. I suppose first part was related to last things you do with Spring Native. What about Jackson introspection and other features supported by Spring? But what about Graal? Like how they works? And also, is it possible to consider native images as a replacement for Electron?
Okay, so let me start with answering first question. Okay, so Honest answer is unfortunately not all the libraries which we have in Spring are ready for native. And I have very good example. For example, as far as I know, Liquibase is not working. Also, if you go to the Spring Native webpage, they will provide with a full comprehensive list of features which are not working with native images yet. I honestly I haven't checked whether uh, JSON introspection works or not, but at least everything which is used for building ordinary REST controllers is working as expected, because the example I had with REST endpoint, it works, and it also uses JSON under the hood, so at least 50-50 works. But still, not everything is working, but worked. Regarding a replacement for Electron, I need to get some clarification. I need to have some clarification here, because what I know about Electron is that it's a, let's say, it's a framework for building applications in JavaScript, building UIs for building, let's say, ordinary thick clients. This is what I know about it. And actually, Java, I suppose, will not be a replacement here, because we're not. It's interesting because actually we're not building a lot of fancy desktop applications in Java. Despite the fact that we have Swing, and Swing is widely used by IntelliJ products, we also have JavaFX. It is not so popular. And I have doubts whether Spring will, whether Java will replace it, whether Java will replace Electron, because this niche is already busy, and it will be quite hard to Java to conquer it again. So as for me, maybe not, because it is quite heavyweight language for writing UI. You may build UI in JavaScript much quicker in comparison with UI you need to build with, for example, Swing. So, but honestly, time will show. Let's see.
Yeah, we have like additional questions like what about like standalone monolith app, I suppose for desktops, and not only using Java but web apps along with BFF on the client side. But I would say I would agree with Alex here that Java, I think Java is taking its niche of backend for enterprise, for servers, and I don't think that it's like a good idea to bring Java on like client desktops as an application. Well, there was tries. Like everyone is remember of applets still, and like Swing and the JavaFX, but still looks like it's not a niche for Java. So yeah, I don't think as well that it will really replace Electron and other frameworks like this. Okay, so we don't have any more questions at the moment, so I would say it's time for wrap up. So Alex, thank you very much for your talk. It was really useful and really interesting introspective of current status of GraalVM and Spring Native. So thank you very much for being here with us.
Thank you very much, Roman, for having me today. I wish all of you good day and productive week.
Yeah, thank you very much. Guys, thank you for being us today. Hope you find this talk interesting. Just a reminder to click like button on this video and also subscribe for our channel and subscribe to our community page. We will have more webinars soon. Link to Java On Conference, which will be in November, where me and Alex are in program committee, so we are already preparing it. You may see this link in the chats. Also, I will put it in the description of this video. Join us, send your talks if you want to be a speaker, or just register for be a participant on the conference. It will be in November, online, totally free, so don't miss it. And also, reminder of feedback. Please spend a couple of minutes to fill it, and thank you very much in advance. That's it for our webinar. Thank you very much for being today with us. See you soon, and have a good week. Bye.
Bye.